Pre-calculus, Chapter 2, Lesson 3, looking at polynomial functions of higher degree, and we've been kind of piecing these things together. We talked about the shapes of the graphs being smooth and continuous. We looked at the end behavior of the graph, so we know how the ends are going to look. What we want to look at now are the zeros of the polynomial function and how that's going to help us graph these functions. The zeros, you remember, are the x-intercepts of the graph, where the graph will cross or touch the x-axis. And remember, on the x-axis, the y values are all 0. Everywhere you go along the x-axis, the y values are 0. So we can solve these quadratics we did by factoring, and that would give us the zeros. In this lesson, most of the polynomials will already be factored, so you won't have to worry about that. But again, the way to determine that is to factor the polynomial, and again, quadratics we know how to factor. Now, once we have it, each factor corresponds to 1 0 of the polynomial. So every factor corresponds to a 0, because again, if we put all those factors multiplied together equal to 0, then any one of those being 0 would make the entire polynomial equal 0. So anything that makes one of these factors 0 is a 0, or a 0 of the function. So that means x minus k would be a 0. Now, when you have x minus a number, or x minus k to a power, what that means is x minus 2 cubed actually means x minus 2 times x minus 2 times x minus 2. And each time, what would make each one of those 0? Well, 2 would make it a 0 each time, so 2 would be a 0 3 times. Let me just kind of show you that real quickly. X minus 2 cubed actually means x minus 2 times x minus 2 times x minus 2. Now, it says here that every one of these corresponds to a 0. What makes this 0? 2. What makes this 0? 2. What makes this 0? 2. So 2 is actually a 0 3 times. And this was what we call the multiplicity of the 0. So the multiplicity, I don't know if that's spelled right, I just kind of scribbled it. So the power actually corresponds to the multiplicity of the 0. So what makes this 0? 2, and it has a multiplicity of 3 times. So for a few examples, if we were to give you the polynomial, so here's f of x is equal to x times x minus 3. Each one of these factors corresponds to a 0 of the polynomial. So what would make this 0? The number 0. And what's the power? 1. So this 0 would have a multiplicity of 1. The 3 would have a multiplicity of 2. 3 would make this 0, and it's used twice. Okay? On the next one here, negative x cubed and x minus 2. Again, this is corresponds to a 0, and this is corresponds to a 0, or a factor as well. So 0 would make this 0 with a multiplicity of 3. 2 would make this 0 with a multiplicity of 1. Please make this little chart like this when you do your homework so it's easy to tell what's what. So here, 1 is the 0 with a multiplicity of 3. Negative 2 is a 0 with a multiplicity of 2. And then for this last example, 7 can never be 0, so that does not correspond to a 0. X minus 3, we could put 3 in here, and it has a multiplicity of 2. Negative 5 in here would have a multiplicity of 4. Okay, so those are zeros and multiplicities, and we did work with those last year, but how does that help us with the graph? And actually, we're not going to look at the little demonstration I have there, but an odd multiplicity means that the graph will cross at that 0. So it will change from positive y values to negative y values at that 0. If it's even multiplicity, the graph will only touch the x-axis at that 0. And let me do a quick example here and show you. If you take an x cubed, okay, what's the 0? 0. And what's its multiplicity? 3. So that means it's going to cross at 0. So here's 0, and we know that a cubic function looks like this. It does cross at the 0. If you take the quadratic, x squared, well, what's the multiplicity, or what's the 0? 0. What's the multiplicity? 2. Because it's an even multiplicity, it should just touch. And again, x squared, we know there's the 0, and we know a parabola comes and touches. So an even multiplicity just touches, and odd multiplicity crosses, so that's why we need to know what these multiplicities are. Okay, so let's do an example here. So list the zeros, give their multiplicity, and then tell whether it crosses or touches. And again, on your homework, if you would put it like this in a chart, it makes it a little bit easier to check your work. All right, so here you have a 0 with a multiplicity of 1. That's odd, which means it will cross. Here you have 3, which is going to have a multiplicity of 2, and that means it's going to touch. So an odd multiplicity crosses, an even multiplicity just touches. All right, next example. 0 has an odd multiplicity of 3, so it's going to cross. 2 has an odd multiplicity of 1, so it's going to cross there as well. So 2 multiplicity of 1. Next example here, 1 has a multiplicity of 3, that's odd, so it's going to cross. Negative 2 has a multiplicity of 2, so it's going to touch. And our last example here, 7 can never be 0. This factor, 3 with a multiplicity of 2, that's even, so it will touch. Here, negative 5 with a multiplicity of 4, which is even, so it will touch there as well. Okay, so those gives us we now know what's going to happen around the zeros of the polynomial. So the next video, we're going to put all this together. We're going to determine what the end behavior looks like. We're going to determine what happens at the zeros. And then we're going to be able to sketch these graphs as we move forward and sketch these polynomial graphs as we use all of that information that we've learned in order to complete these polynomial function graphs.